Ho, ho, ho! I know it might be maybe a little bit too soon to already call out Santa Claus, as we first have to go through one of my favorite weeks this year, called the Azure Advent Calendar Weeks. I already want to thank you for being here, having signed up for the calendar week, but also a special thanks to Gregor and Pixel Robot and all other ones involved in putting this show together. My name is Peter D. Tender. I'm an Azure technical trainer within EMEA out of Microsoft. Before that, I was running my own business, Microsoft Consulting, Microsoft Architecting, and providing readiness workshops, of which the last 6 years was pretty much oriented around Azure. Traveling the world for about 90% of my time, providing workshops to larger Microsoft partners, customers, and Microsoft internal. I recently joined Microsoft early September this year, but in the end my job is not really changed compared to what I did before. In the little bit of free time that I have, meaning staying at airports and boring hotel rooms, I actually found a hobby in writing technical books, obviously on Azure topics. So feel free to check Apress or Pact if you're looking for some nice content on using the Azure platform. Outside of that, feel free to stay in touch or reach out whenever having questions on Azure, where you could use my email address petender@microsoft.com or reach out on Twitter pdtit or 007FFF Learning. In the next 20, maybe 30 minutes, I'm going to introduce you to the cool world of containers, and more specifically, how you can run those containers on Azure using Azure Container Instance as one of the examples. The flow I'm going to use for the presentation is the following. I'm going to start with positioning containers and actually highlighting why everybody's talking about containers nowadays. Then jumping over to what you need to know to run containers in Azure and what the different services we are out of the platform. And then zooming in on Azure Container Instance, the core topic of this presentation, wrapping it up with some demos and probably some more demos, starting from a Docker image on my local machine, moving it to Azure Container Registry, and from there running it in a live running container instance. So with that, let's kick off this session and tackling the first question. What are containers? Now, I always like to describe a container as a stripped down virtual machine, offering you a packaged unit of binaries, applications, and data. Now, important to highlight is that a container is typically able to serve a single purpose. So for example, the workload that I will use in my demos is a .NET Core e-commerce web application. This also means that if you want to provide another purpose to a container, like running Node.js, running Java, you need to create a new container. And as the .NET Core has no idea about running Node.js or any other language. Now I already started with serving one purpose of a container running web applications, but know that containers can run pretty much anything. Some containers, like a popular one, is Ubuntu, and that's going to give you a stripped down Ubuntu kernel, almost looking like a full Ubuntu virtual machine, but it's not a virtual machine. Or even from a different angle, running SQL Server, which used to be one of those heavy workloads, are now also available running within a container. Now the side note is that out of Microsoft, we're not really recommending it for production workloads, but it's at least helping you in building some cool demos if you ask me. Now back to the containers, it's also important to highlight that you can have Windows containers as well as Linux-based containers. So depending a bit on the workload, you might use one or the other. A little point of confusion is the operating system. Why? Because containers as such don't really have an operating system built inside the container, but they rely on the shared operating system kernel from the underlying container host. In between, the service taking care of isolation and making sure that your container runs in the most optimized way is known as the Docker daemon on Linux or Docker engine on Windows. Now you know a little bit what containers are. Let's share a few of the benefits and obviously why containers are so popular. The main benefit to me is that a container, and more precisely the container image, is a bundled, packaged unit of everything you need to run for that given workload. So using the same web application again as an example, my container will have the kernel, the required binaries to run .NET Core, and outside of that, I'm also injecting my source code in there. Another big advantage for running containers is the overall standardization. As long as you're running the Docker engine or Docker daemon, your container will run. And it's even better because it will run anywhere. So if you deploy your workstation like the one I'm using for my demos here, it's a Windows 10 on which I installed the Docker desktop. One of my colleagues could perfectly run an Ubuntu operating system as a client, installing the Docker daemon and still being able to run my container. You could run it on top of virtual machines, again Windows or Linux, in which you install the Docker engine, or what I'm going to show you throughout the presentation is how to run it on top of the Azure platform, but again you could run it outside of Azure as well, on AWS, Google Cloud, or any other hosting platform that's offering you the Docker daemon. Another benefit for running containers is that compared to a full-blown virtual machine, the startup time is a lot faster. And again, probably most important, a container serves a single purpose. So with that, let's jump to my demo environment and quickly showing you a little bit about what I mean in using the Docker daemon. Now I'm running my demos from within PowerShell, but nothing would block you from running this in a command line. And again, if you're using Linux, it might already be part of your operating system anyway. So before this, I installed Docker Desktop, so you can easily download it from the docker.com website and run it on your local machine. From here, you could run Docker info. That's gonna validate that the Docker engine is actually working fine, and also providing you some information about your Docker environment. So as you can see, I'm running the latest version 1903. I got 17 containers and none of them are running. But on top of that, I got 18 different images. And I'll talk about the differences in the next couple of minutes. Outside of that, mainly some version numbers where, again, up here, I'm running Docker Desktop. It's on top of my 64-bit. And funny enough, although I'm running Windows, the operating system type is actually Linux. Now, just a side information. Again, the power of the Docker container layer, if you want, is really the openness that it runs on pretty much any platform. Now, if you run a Windows client like myself, and you still want to be able to run Linux containers, you can easily switch from one version to the other. Now, you don't need to deploy any like dual boot on your local physical laptop, but you could just install or flag the Docker engine for Linux, and in the backend it's going to install a little virtual machine that you never need to manage. It's just part of that Docker desktop flavor. From here, I could run Docker images, and that's going to show you a list of all the images I have on my local machine. So from here, let's say I want to run Docker run Ubuntu. That's going to start up my Ubuntu image and running it as a container. Now, obviously not a lot is happening, although I'm actually pretty sure that my container is running. Let's validate using Docker container list, where it's actually not running. So what do you tell me? Hey, Peter, are you joking? You tried to do something, it's not working. No. So the core purpose of a container is starting up, and when there's not a lot happening, it's actually shutting down again. Why? Because we're not telling the container what to do in that Docker run Ubuntu command. So let's try something else. Let's do Docker run, this time in interactive mode, which requires the parameter IT and pointing to Ubuntu again. For now, this time, what's actually happening is that I'm no longer inside my Windows environment, but I'm actually inside my running Docker container. From here, I can do list, and as you can see, I'm within my operating system, like a little stripped down Ubuntu client. You can do some more fancy stuff here, like if you have any specific applications running inside the Ubuntu container already, you can actually start that one up right away. From here, I can exit, and now I'm back on my Windows operating system. Let me do the same. So I'm going to again starting up, and then let me open up a second instance of my PowerShell. Where this time, if I'm running Docker container list, it's actually going to show me that that Ubuntu container is running. And the command within the container is down here, starting the bash command. So basically giving me the command prompt. From here, I could do docker stop container, pointing to the name or the unique ID up here, and that will stop my container as well. And even there, you don't need to provide the full, because the container ID is always unique for that one running container. So if I stop it from here, then as you can see in the other PowerShell window in the back, it's also exiting my container in a nice graceful way. There's a lot more on Docker command line, but the core topic is Azure Container Instance. So with that, let's move on with some more details about that part. So we now have our Docker environment up and running. So the next question is, how do I run my containers on Azure? First of all, Azure comes with a couple of different services available that you can choose from to run your containers. It all depends on a lot more details than I can cover in just a 20-minute session, but it's giving you a couple of different capabilities based on load balancing requirements, based on performance requirements, or based on aspects I already talked about before. If you have a multi-cloud strategy within your organization, you might maybe look at one service compared to the other. Now, one of the first components that you need for running containers on Azure is Container Registry, and I'll talk about it in the next couple of slides. But in short, it's a location, a registry, like a library of container images. Then the core I'll cover later on in some demos is Container Instance. As you can figure out, it allows you to run an instance of a container. Another service we have available in Azure to run containers is Azure Web Apps for containers. I know it might sound a little bit confusing, but what we're actually doing there is giving you all the capabilities and characteristics of running Azure Web Apps. But instead of pushing out and running the source code, you're going to push out and run a container. And then lastly, probably one of the most popular ones or well-known ones is Azure Kubernetes Service, or AKS, where out of Microsoft we provide you a full Kubernetes clustered environment as a service, allowing you to run massive containerized workloads, providing rolling upgrades and scalability. So let me talk a little bit about Container Registry. So again, Container Registry is the landing page, the repository for storing your offline container images. Similar to a public registry like Docker Hub that I'll talk about in my next demo, but it's typically used in a more private model within your organization, within your Azure subscription. If you deploy the Azure Container Registry Premium SKU, then it also provides you a benefit that you can upload, push your container images into one single registry, and it's going to replicate across multiple regions, which is obviously interesting if you got multiple container workloads running across different regions where you don't have to handle multiple registries or facing latency. If your container, for example, is running in West Europe, but your containers are somewhere running in East US. Now, to make sure that your offline container images can actually be pushed into a container registry, you got to make sure that you add a tag to your container that's corresponding to the name of the Azure Container Registry itself. And with that, another demo where I'm going to walk you through the deployment and use case for Azure Container Registry. Now, first, let me talk about the public. So first, let me talk about the public Docker Hub. So if you go to hub.docker.com, it's a public library of container images. So from here, I could search for, let's say, Microsoft or why not, it doesn't always need to be Microsoft technology, let's say Java. So what I can do here is scrolling to that list of pretty much 21,000 container images that do something with Azure. So from here, I can find like a Oracle Java 8, pretty obvious. That's going to show me or allow me to run my Java 8 based application, or the Node.js is probably a container allowing me to run Node.js JavaScript based container application workloads. Now to prepare my demo a little bit, so I built my own e-commerce, well, not really my own, it's an open source called Simple Commerce. And what I did there is running it on my local machine out of Visual Studio, packaging into a container. There's a lot more to talk about, but that would be another session maybe for next year's Azure Advanced Calendar, how to containerize applications using Visual Studio. But bottom line is I built my container out of my source code of the application and uploading it into Docker Hub. So if you want, you could go back to your Docker command line and actually running your container. Why? Because the only thing you need to do is Docker run interactive and pointing to the name of the container. The first step, if you don't have the container running locally or having it on your local machine, is that it will download this from the Docker public repo. And as you can see here, it's telling me that my application is running fine. I'm not going to test it out for now because I need to talk about some other registry stuff. But again, this is the Docker Hub that you're typically going to use for storing or grabbing, pooling as we call it in Docker terms, public stored container images. Now back to my Azure Container Registry. Why? Because we want to create our own registry from here. Similar to other Azure Container workloads, it starts with creating an Azure resource. So I'm going to provide a name, the PDT simple ACR, making sure that the name is unique across all container registries worldwide. And I'm going to create a new resource group called PDT simple ACR. Why not? Enabling admin user permissions. There's a lot more. In like a full production environment, you would not just open it up, but create like a Azure Active Directory service principal to do that. And you can define the SKU, like what is the version, the flavor, and the cost corresponding to it. Where again, the use case for premium would be in like a full professional environment where you're heavily running containers, storing a lot amount of containers in the registry, and again, giving you that replication across multiple Azure regions. For now, I think my basic would probably be good enough to serve the purpose of the demo. And from here, it's going to take just a couple of minutes to actually create that instance. Now, another approach to running this is, let me kill my container from here. I'm not going to kill it, I'm just going to stop it. And running a creation using command line. So what I did to do that is installing the AZ command line options on my local machine. You could also run it using PowerShell. So I know this might be a little bit confusing since I'm in a PowerShell window, but not actually running PowerShell code. So first I need to create a new resource group in Azure. And for that, we're going to use AZ group create. Providing the name of my resource group, let's say ACR CLI resource group, and the location West Europe. And maybe providing the correct parameter settings as well. And if all goes fine, that should give me my resource group. There we go. And from here, I could do ACR create, so create a new Azure Container Registry, pointing to the resource group, ACR CLI resource group, specifying the name of my container, why not the ACR CLI, this queue, and again gonna enable the admin integration. And again, this will take just a couple of minutes, similar to what was running in the backend. Actually a lot faster, way cool. I love Azure CLI. So this means if I refresh, then it should be there. The other one is probably coming up in just a couple of seconds. I'm not gonna wait for that. So up till now, I deployed my Azure Container Registry. Now the next thing I'm gonna do is pushing out my container. So back to my local Docker environment and checking back the Docker images that I have. Now from here, I have my Docker image that I grabbed from my Docker public hub, where the next step I need to do in order to integrate this with my Docker environment is running a docker push command. Now, as I told you in the slide, before the Docker registry can actually accept my Docker image, I need to make sure that it reflects the name of my registry. Now, I speeded up the demo a little bit here, but what I actually do is Docker tag, so adding a tag to the existing container that's referring to this name of my instance, or my container registry, sorry. I know I had another one, but as you can see it CAR, which is not the correct name of my registry. Now just to show you how it's working, let's say docker push, docker tag. My source container image, where this time it's the PDT ACR CLI, the one I created using CLI. Something like this. And if I check back with Docker images, it's still gonna have my source. That's this one. It's still gonna have the other two ones that I created already. And now it also has the new one. Now interesting is this image ID here on the side, where you can see that all four of these are actually pointing to the same container image. So it looks like it's four different ones, but technically there's no difference. It's just a tag that I added into it. And then from here, I'm gonna run docker push, the PDT simple ACR, now out of that, it's recognizing my container registry and it's already uploading. Or actually it's not. Why not? Because obviously there is some protection in the Azure environment because we take security pretty serious. And what we need is authentication. Now what this means is that from my local machine, I actually need to provide my Azure admin credentials to make sure I can actually connect and authenticate to my ACR. Now to do that, I'm going to use ACR login, pointing at the name of my resource group. First my PDT simple ACR and the name of my resource group, which was the PDT simple ACR. Let me just validate if that's actually correct. PDT simple ACR and PDT simple ACR. That should do it. So now it tells me login succeeded. So let me try the docker push again. this looks way better. So now it's uploading my Docker image from my local machine into the Azure Container Registry. So I keep this running for now, and why not jumping to the next part in the presentation, talking about Azure Container Instance. Now, Azure Container Instance allows you to run containers as a single instance using a single command. So easy said, if you have a Docker image that just needs to run, you're going to hand it over to ACR, from there pointing and running it in Container Instance, and it will take care of just that, running the container. Another advantage of using Azure Container Instance is the per second billing. This is really useful when your containers are not running 24/7. I have a few customers where running the same workload in a container instance compared to running it inside virtual machines is resulting in a 40% cost reduction. Another aspect of ACI is that it's truly offered as a service. So there's no virtual machines for you to deploy, to manage, to patch. It just gives you the service you need to run your containers. Last, ACI supports Linux and Windows containers. You just need to specify during your container instance configuration which flavor you want to use. And next to that, you can also customize certain container instance characteristics like CPU and memory you want to allocate to that specific running instance. If you're wondering how organizations are using ACI, I can share a few use cases I've seen in the field. Given the per second billing, it's the ideal candidate for running temporary workloads, like running transactions overnight and stopping when finished. Another is running it for overall data processing jobs. Think of machine learning, data analytics alike scenarios. Or another one is having it integrated with other event-driven applications out of Azure Functions or using Azure Logic apps. Starting up a container in ACI based on a certain event triggered by the serverless functions in Azure. Or lastly, thinking again about this boxed, isolated aspect of the workload, it can also be used for doing cool demos of running applications. So for example, if you're an ISV, where before you had to deploy virtual machines, or even handing it over to customers, asking them to deploy a certain environment, giving a documentation where now you could basically just point them to that running container image in Docker Hub or even your container registry and sharing it from there. Now, although Azure Container Instances are pretty cool, just to be complete, I also need to talk a little bit about limitations. And again, it all depends on specific use cases, on how you as an organization want to run your containers. Now, just from the top of my head, I could come up with 4 limitations. And again, I don't really see those as like blockers for not using ACI. It's just that we got other services in the platform that might be better suited for running in that kind of requirement scenarios. So first off, when you want to execute upgrades or updates, your containers are facing downtime. Now, knowing that containers are coming up in just a split second, this should not always be a dramatic. If you have a need for scaling to make sure that your application can handle the load requests, know that ACI is providing limited scaling functionalities, and it even lacks integration with load balancing. Now, technically, nothing would block you from deploying your own load balancing solution on Azure and pointing to multiple running instances, but it just feels more complicated. And another one I could come up with is that if you have different containers that need to communicate with each other, it might also be harder to configure and realize this with ACI. Now, in short, you might already know the answer. You could have a look at web apps for containers, or why not having a look at Azure Kubernetes services. And I'm actually pretty sure that we do have another session here during the Azure Advent weeks that's going to cover a little bit on Kubernetes. Now back to my demo environment, where if all goes fine, my push is complete, and that will allow me to actually spin up a container instance. So I'm going to refresh. There we go. So this is my registry again. Out of my repositories, I should have my simple commerce, Docker image, and from here I can spin up a new instance. Or another option is starting from container instances and adding a new one from here, pointing to my container registry. Either options work, so it's really up to you to find out which way is the best. And I'm going to keep using my portal from now, but know that you can also deploy container instances out of PowerShell or command line, or even using Azure Resource Manager templates. So I'm going to use my simple ACI Registry and Resource group, where the name of my container is the simple commerce running in West Europe. And this time it's using a private one. So from here, I need to provide the name of my image, the registry, login, server, everything. Now what I'm going to do, just to speed up the demo a little bit, is going back to my registry and actually starting it from there. Why? Because then I don't need to provide all those details, and the result will be the same in the end anyway. So what name do I want to give to my container? Let's do the simple PDT commerce. Since it's a .NET Core, I can run it on top of Linux, but nothing would block you from flipping over to a Windows flavor here. I deployed it in North Europe, and down here I can specify the amount of cores. So one instance can have up to 8 CPUs, and I can specify a certain amount of memory. Now for my demo, I don't need a super performing instance, so I'm gonna keep the settings as is. And you can also decide if you want to open up the container running workload to the public internet or not. And then lastly, the port you want to use. Since again, this is a web application, port 80 will be perfect for this scenario. So this is going to take about a minute. So it's creating my container instance. So let's go back to the container instances. It's not fully deployed yet, but just want to walk you through a little bit of the monitoring feedback we share. So that's the name of my container. That's the pending state because it's still starting up. And from my settings pane here, I can actually follow what's going on in the backend. So it starts with pulling image, then pulling off the image itself. So it's connecting the container registry and copying it over from there to a running container instance service. That's happened up here, successfully pulled my image. Then it's going to start it, creating it, and as you could see, everything's up and running. So if I refresh, then the running state is what I needed to see, which also means that I got a public IP address here, and bring to the demo guts that it's going to show me my web application. Awesome. That's basically why I so much like Docker containers and container instance. I started from my local machine, pushing it out, running it in container registry, handing it over to container instance, and it's running. Only thing it's going to do right now in the backend, but that's specific to my workload, is creating an in-container database flavor and allowing me to run this as a full e-commerce environment. Pretty cool. So with that, let's close off my presentation, where in the last 20-something minutes, I introduced you to the wonderful world of containers, talked about why everybody's talking about them, how you could run them on Azure, highlighting the couple of different Azure services we have that provide you container integration. And then, most important, talked about the beauty of Azure Container Instance. I hope I kept it pretty exciting and entertaining for you, but there's a lot more. So again, we do have Azure Advent Calendar. Since you're watching this session, I'm pretty sure you already know where to find it and how to find it. Follow us on Twitter, tweet about the sessions, make some buzz around it using the hashtag Azure Advent Calendar. And with that, wishing you already happy holidays, hoping to stay in touch in some way, one or the other, hoping to see you again in the next year and working with some more Azure stuff. Take care for now and have a nice rest of the day.